In this class, we study miscellaneous forces, the various non-fundamental forces that are quite important in our daily lives. First, we can consider normal force. Normal force is applying to an object that is pressing down the surface, and the surface cannot win the game, just cancel the force of pressing down. So it's opposite to the applied force. However, that direction is only normal, perpendicular to the plane. Hence, if the applied force has some angle, that force must be decomposed into the perpendicular component and the parallel component. Only the perpendicular component cancels due to the normal force. That's quite important. Next one is the frictional force. Frictional force is inevitable and unavoidable in our daily life. If there is no frictional force, car accident may happen so many times, and even the car cannot be driven. You cannot write something on paper because you cannot hold a pencil. You cannot open the door because if there is no frictional force, you cannot rotate the door lock. So you cannot open the door. You cannot walk. You cannot drive a car. Serious problem. But in many cases, we want to erase the effect of the friction to increase the speed. Anyway, frictional force is proportional to the normal force. And there's a simple relationship. The formula for the kinetic friction is quite simple. And formula for the static friction is a little bit complicated. It looks very similar. First of all, it is proportional to the normal force. Second, it is proportional to the coefficient. What kind of coefficient? The frictional coefficient. Kinetic frictional force is fixed as long as the normal force is fixed and the surface is uniform. Static frictional force is similar, however, it has a maximum value. That means it is variable. It can be 0 if there is no force applied. If no normal force applied to an object. But until the applied force wins the game with the static frictional force, it flips to the state of kinetic frictional force. So static frictional force increases as the applied force increases along the direction of motion. For a small force, the static frictional force cancels. A bigger one still cancels, but at some point, that is the maximum value of static friction. Still cancel, but if it is just above the applied force, just above the maximum value of static friction, the object starts to move, and suddenly the static frictional force is replaced with the kinetic frictional force, and at that moment we can compare these two, and static frictional coefficient is slightly greater than the kinetic frictional coefficient. all of the miscellaneous forces are based on, it can be decomposed into fundamental forces. And usually what we study is mostly gravitational, either gravitational force or electrostatic force, and sometimes a magnetic force. And there are four fundamental forces: gravitational force, or interaction, electrostatic force, and magnetic force. However, electrostatic force and magnetic force are combined into electromagnetic force because of the relativity. Einstein's is not a Galilean relativity. Instead, it is Einstein's relativity. According to relativity, electrostatic force and magnetic force are three components for electric field. The three components are magnetic field. They are actually the six components of F mu nu, that is the field strength tensor of the electromagnetic field. And they transform, these six components transform among one another based on the Lorentz transformation. Anyway, these are the most important forces we are very familiar. However, these forces cannot explain the basic elementary particle. For example, within an atom, there's a nucleus. Nucleus is composed of nucleons. Nucleons are either proton or neutron. And neutron is electrically neutral, but nobody knows if we stick to these forces. There's no way to explain that electrically neutral particles are within a very tiny space called nucleus. Furthermore, protons are charged particles, and equally charged particle, same sign, charges of the same sign interact with a repulsive force. Enormously large repulsive force should present the electrostatic viewpoint. However, there is a much stronger force that is called nuclear force, that is either a weak interaction or strong interaction. So gravitational force, electromagnetic force, weak force, and strong force, they are four fundamental forces. But due to the development of quantum field theory, we were able to unify the electrostatic force and weak force all together as a single theory. There's electroweak theory. And it is combined with the theory of quark communicating with each other with gluon exchange. We have a strong interaction. Electroweak theory, strong interaction. And they are consistent. And finally, these two sets are well explained within the quantum field theory. However, gravitational forces are not yet developed as a quantum field theoretical viewpoint, because it is according to the general relativity, gravitation is closely related to the space structure of our space universe. The gravity due to the distribution of mass change the shape of geometry of the space. Okay. additional miscellaneous force is tension. Tension applies to object that is connected by string. In this case, the tension is loosened, that it cannot give and take some force. As long as the string is tight enough, two objects can communicate with each other with the tension. So tension gives the force in this direction. So tension is attractive to object. So it is impossible to have a repulsive force between two if they communicate with the tension. The tension is always tangent to the curvature. Exercise. Consider an object on the floor. This one has a mass, so it has a weight mg, and it is a flat, so the flat and the surface is stable, so normal force always cancel the force that is perpendicular to pressing down on the surface with an angle perpendicular to the surface. So if it is moving, if it is not moving, and if there is no applied force, that's it. But if there is some force, there is a frictional force proportional to the normal force mg in this case, and the direction is opposite to the velocity. Suppose that we have a force applied to this object that is parallel to the surface, then the whole amount of this external force, some part of this force cancelled by the state of kinetic frictional force. Okay? And the kinetic friction force magnitude is determined by the normal force. Let's consider a little bit complicated situation. The force applied force is not parallel to the surface, but has some angle. In that case, we can decompose this force F into two pieces. One is a parallel, that is F cosine theta, parallel to the motion and parallel to the surface. And another component that is perpendicular to the surface. So the normal force and F sine theta, they are parallel, F sine theta. And the weight, if we choose E2 to be upward, weight mg is applied in here to cancel the vertical direction relative to the surface. Hence, we have this kind of constraint. And the normal force is, if we move these two terms to the right side, normal force is mg minus F sine theta. And the direction is E2, parallel to E2 and vector. And then the net force is only along the parallel direction, this direction, parallel to the acceleration. So the acceleration is due to the net force of this and this. Okay? F cosine theta is the parallel component to the motion, and the backward, there is a backward force that is a kinetic friction. We now have to multiply the normal force, and normal force has been determined like that. That is given in here. So we have determined the acceleration as it is. We make a rotation about 90 degrees, and there is some friction. The object has a small mass m, so it has the gravitational force mg to the ground. Because gravitational force is parallel to the surface, it has no contribution at all for the pressing down. There should be some force to press down the object to make a non-vanishing frictional force. The force is applied to the normal direction, opposite to the normal direction, and the normal force must cancel these two unless it is broken down. But then the maximum value of the static frictional force is determined by the magnitude of the pressing down, the force pressing down on the block. If this maximum value is greater than weight, then it is always okay. It is not sliding down. As soon as it decrease the force as small as possible, and at some point you can reach the point these two magnitudes are the same and a little bit bigger, so you decrease a little bit more, then this block starts to sliding down. After that, it will acquire the frictional force, not static, but kinetic. We can consider the motion of two blocks. There's a frictional force and there's a weight, and they communicate with each other through tension. If there is no friction and there is no negligible mass for the pulley, the pulley's action is only to change the direction of tension. The magnitude of tension should be the same. So when we increase the mass of the small block hanging on a string, we have mass capital M. mg is the weight of this block. The same amount of force is the normal force. Because of the normal force, there should be static frictional force maximum value. So mu s mg. If this static frictional force is greater than this mg, this is F max S, then this system is stationary. However, as soon as this small mg is bigger than the maximum value of the static friction, the system starts to move. This is a uniform acceleration. the car begins to decelerate at t0, and it makes a complete stop after additional time t, capital T, has passed. We can make use of the formula v2 squared minus v1 squared 2a equals the displacement we derived when we studied the one-dimensional motion. This relation is related to the kinetic energy formula for the simplest case, the work kinetic energy formula, and we derived this using trapezoid for the uniform acceleration. When we solve the equation of motion, we frequently encounter linear equation. We begin with solving 2 by 2 two variable linear equation. On the next page, we have to solve the linear equation, so we cannot escape from finding the solution of the 2 by 2 matrix inverse. Suppose that we have linear equation. For example, when we want to solve the tension of a system, massive system that are connected with two strings, T1 and T2 will be the tension of the system, and we have mass M1, M2, M3, and we apply some force. Then we need to determine these variables. So when we want to solve each solution, then we have to find the linear solution of the linear equation. For simplicity, we introduce a linear equation ax by equals p, cx plus dy equals q. These are just, let us consider these are the component of vectors in Cartesian coordinate system. Then the first one is a, b, and xy, and the second line can be written as a cd xy. So if we combine these two, a, b, c, d, xy, and the first equation is p, the second equation is q. If we combine these two, we have the matrix equation. We say this is a matrix A, and this is X, and we have P vector. If we know the inverse of this, that means A inverse times A is identity matrix. If we can find the inverse, then we can multiply both sides with inverse. Then because it's identity, for example, 1, 0, 0, 1, xy, if I multiply this, nothing changes. So if I know this matrix, the solution x and y should be the A inverse P. So what is it A inverse? That's the question. The answer is very simple. Okay. We have A, capital A, that is A, B, C, D. First, this solution exists only if the determinant is non-vanishing. Why? This is AB and this is CD. This is two-dimensional vector. For example, there are two vectors, alpha and beta. And Cartesian components are A comma B. That means A E1 hat and B E2 hat. This one is C E1 hat plus D E2 hat. This equation is solvable only if the two vectors are not parallel. Sure, if they are parallel and if they are exactly match, then the solution is everything. However, if the two lines are parallel and has some non-vanishing distance, then there is no solution. In two dimension, two lines with different slope always meet at a single point, but there is a single unique solution. So, how can I determine these two are either parallel or anti-parallel? Because of Descartes, we know how can we determine this? Determine whether parallel or not. Determine. So this is the determinant. Determinant. You can determine whether these alpha and beta are parallel or not. How? Compute the cross product. Alpha cross beta is the cross product. If they are parallel, this parallelogram is just flat and it does not make any area at all. How can I compute the cross product? It's easy. Let us compute the cross product. Because it is two dimensional, we have a vanishing z component. E1, E2, E3, AB, 0, CD, 0. This is the determinant. That is alpha cross beta. Okay? How can I compute this determinant? Everything is 0 except that E3 determinant ABCD. Determinant ABCD is too easy. AD minus BC. E3 hat. Aha. So if it is non-vanishing, the solution exists uniquely. That's the reason why determinant ADBC is quite important. Let's copy the determinant AD minus BC. All right. So to simplify our analysis, we assume that determinant is non-zero. All right. I would write this inverse matrix in units of determinant. In physics, unit is very important. So to simplify the calculation, I rewrite this A inverse matrix in units of determinant, the area of the parallelogram. But ideally to say something, it should be something. Don't be afraid. I have ADBC. Just copy it above. A inverse in units of determinant, and I know nothing. However, I know everything. Quantum jump. I know everything. Quantum jump. The answer, because I know the answer. The product should be 1, 1, 0, 0. And what? And I also know the matrix A, B, C, D. And I know the answer 1, 1, 0, 0. Hey, if it is 1, haha. If these two elements are completely determined, why? I have denominator AD minus BC, and I have the answer 1. How can I get 1? Multiply this one and this one. And I must have AD. Absolutely. It's completely fixed. And then, what should I do? C is multiplied to this empty number. Oh, this is the answer, minus BC. Oh, minus B should be there. What should I do next? Let me find this one. To find this one, I multiply this one to here. ADBC, B minus C. And this one is multiplied to here. D. D. A is the answer. I know the answer for the inverse is trivial. AD minus BC and D minus B minus CA. Whatever ABCD, as long as their determinant is not vanishing, I can find any matrix inverse. Nobody told you I copied nothing from any mathematics book. Mathematics book doesn't teach in this simple way. This is a physicist way to solve the problem. So we have inverse matrix. Whatever PQ you may have, I can give you the answer. Just multiply P and Q to find the answer. Perhaps if you take the mathematics course, you might need 1 month to answer this question. But I need to solve many physics problems immediately. I do not have any time to learn mathematics from mathematics class. So this is physical mathematics. Physicist does solve problem in this way, in a straightforward way. Is it rigorous? It is just arithmetic. Very simple. Nothing to be proven. Just please distinguish physics from mathematics. In physics, we do not ask you provide any rigorous, tedious proof. What we need is just an answer, and you just follow the simple way how physicists does solve mathematical problem. But those mathematical problems not coming from mathematics, it is based on physics, and the physics answer is evident. Very, very simple. Okay, this is the first application of the solving linear equation to a physical system. We have two masses, capital M and small m. They are attached to a string, and this string has a tension. As long as this pulley has no mass, sure, if a particle does not have any mass, it should fly with the speed of light. But I don't say it is massless, but it has a negligible mass. And if there is no friction, the role of the pulley is just to change the direction of the tension. The magnitude of tension on both sides should be the same. And this string is unstretchable. The length of the string doesn't change at all. Then we can construct two equations of motion. We have a free body diagram for the capital M, the tension, normal force, and gravitational force, and another free body diagram for this small m, weight, and tension. And this guy is moving with the acceleration a downward. This guy is moving up the slope with the acceleration a. Then I have two equations of motion. Additional force I have missed is the frictional force downward. But you can always simply reproduce this, the magnitude of this weight mg is separated into, decomposed into two pieces. Down the slope is mg sine theta. The pressing down the slope is mg cosine theta, and that should be cancelled by the normal force, that is mg cosine theta. And mg cosine theta determines the magnitude of the kinetic frictional force by multiplying the coefficient mu k. The sum of this and this will determine the net force on this block downward. The opposite direction, there is a tension. And the other equation motion is a trivial. It is moving down with the acceleration a, so ma equals mg subtracted by t. We have two linear equations with two variables t and a. Haha, this is the right time to make use of this solving the linear equation. And the answer will be obtained like that. Next, we consider drag force. Drag force is due to the resistance of air. There's a kind of air friction. And it depends on the velocity, and it is proportional to square. But even higher velocity, it is approximately v to the nth, and the power varies depending on the situation. It is not a fundamental force. It is almost impossible to compute how the power is determined, because the nature of a fluid is not ideal, and it is determined phenomenologically. However, in fact, it is quite important if you launch a rocket to be away from the Earth, to shoot a satellite. Very important in practice. Anyway, because of the variable nature of this force, when you increase the velocity, the drag force strictly increases, and the slope is even steeper and steeper as the velocity increases. Under the constant force, for example, uniform gravitational acceleration, it always hits. Therefore, however, this is a resisting force. It cannot win the game with any other external force. So, as soon as it touches the gravitational force, that is the external net force, it cancels and never be increased more. So when we reach the point where the drag force equal to the gravitational force, it stops to accelerate. It can only decelerate the acceleration. It cannot decelerate more to opposite direction. Because of that, drag force and gravitational force cancel. So if we require this is 0, then we can solve the velocity where these two forces, gravitational force and drag force, cancel. In case we have power 2, then the answer is this. We can study in a similar situation in a sticky fluid, in the damping force and the slower velocity. That drag force is modified into damping force that is proportional to the velocity. Even though it is not fundamental, it is practically very useful. The damping system is used for the door stopper, or the this force is again opposite to the motion. There's a velocity, and we have a unit vector along the velocity, and its direction is a minus unit vector of the velocity. And we use the coefficient B that determines the strength of the damping force. We apply this damping force on a freely falling body, then the Newton's law of motion gives F equals ma. And that F is the sum of superposition of two forces, mg, that is the gravitational force, and in opposite direction we have bx dot. We have mg and bx minus bx dot, that is opposite to the motion. So the x in here increases as the falling body goes forward. You might want to stop considering because it is a differential equation. If you stop, then you learn differential equation, and it might take 1 year to return to solve this problem. But in a minute, we can solve this problem in a physical way. We don't need math class to solve physics problem at all. Let us replace x dot, that is velocity. Then x double dot is a velocity dot. And I don't like this mass m. Let us scale this equation with mass. Then it becomes x double dot equals minus b over m x dot plus g. And let us introduce a simple parameter. B over m is redefined by gamma. If we substitute these, v dot equals minus gamma v plus g. And v dot is dv over dt. Mathematician says it's a separation of variables. We have v's and we have t. Why don't we separate them? We multiply dt both sides. And divide this one both sides. Well, why don't we keep gamma, minus gamma in here? Then this is v minus g over gamma. What a simple equation it is. We can integrate. This is a log. This is just a simple t. Why don't we choose v0 to be v at t equals 0? This integration is log v minus g over gamma, and initial value v0 minus g over gamma, and right side is a minus gamma t. we have integrated from 0 to t. Alright? Log. This is a simple g over gamma v0 g over gamma equals exponential minus gamma t. Alright, we are almost there. V minus g over gamma equals v0 minus g over gamma exponential minus gamma t. V of t equals g over gamma plus v0 minus g over gamma e to the minus gamma t. Now we can integrate over time, then x of t equals x0 plus g over gamma t and plus v0. This is constant. G over gamma, and this integral exponential at dt 0 to t equals a 1 over a e to the at. Substitute 1 0, that is 1 over a e to the a, not 1, this t, at minus 1. A equals a minus gamma. So 1 over gamma, 1 minus e to the minus gamma t is the answer. This is the answer. This is the answer. What we have done is just additional expansion. So when you solve the physics problem, do not think about the math class. Just follow the physical way to solve it. That's it. Uniform circular motion. We have done a lot of work on the uniform circular motion. So let me pass. In the self-test, we return to the same problem. In the previous class, we studied the center of mass. So perhaps I need to explain what the center of mass and what the reduced mass is. Again, we find some linear equation, two variable linear equation. We have to solve the linear equation. Oh, how can I solve the linear equation? That answer is given already in here. You find how to solve the linear equation. It's a very easy way to find out the solution for the linear equation. And here we have two objects. We know how to compute the frictional force, compute the force that pressing down the floor, and compute the normal force that cancel the applied force mg. And there should be the normal force, and the normal force is determined. It determines the, here it is kinetic frictional force. We have acceleration here. It is making a motion. Okay, the net force on the system is gravitational force cancelled by the normal force, but in here we have frictional force backward, tension, tension, and then gravitational force. If this gravitational force is cancelled by the normal force, this gravitational force really applies. And we have a tension. Alright. We have two free body equations. And this is friction, tension, gravity. So we have two linear equations. We have acceleration, a and t, two unknown variables, two equations. We need to solve a system of linear equations. But I know how to compute inverse matrix. 2 by 2 inverse matrix are trivial. Okay, you can solve this problem. But here we have another point to consider: the system of particles. The system is composed of two masses. In this problem, it is a capital M, M1 is capital M, the other is a small m. Let me use position vector x1 for the capital M and position vector for x2 for small m. And x1 is moving parallel to the floor, the shelf, that is E1. And we have another mass that is going down. Let me choose the unit vector, use unit Cartesian vector, basis vector, to be E2. In here, there's no friction. Vanishing friction. Even simpler problem. You go away, no friction. So we have tension only. Simple. So the acceleration multiplied mass by the mass is the net force, and net force is the tension only. And the other one has gravitational acceleration, gravitational force subtracted by the tension. All right. So let me remove the unit vector and t equals ma. Here, let me remove E2. Then we have ma equals mg minus t. If we substitute in this, eliminate t, the tension is removed, and ma. And if we move this, small m, capital M, a equals mg. So acceleration is very simple. If you substitute this acceleration in here, you have m and small m, g over capital M plus the small m. That is tension. So acceleration is this, and tension is not the gravitational acceleration, but gravitational acceleration multiplied by reduced mass. Reduced mass is the product divided by sum of the two masses. So this typical mass for the very important mass for the two-body system. You remember we defined the relative coordinate x2 minus x1 to be our vector. In that case, in the center of mass frame, center of mass, what's the center of mass? Center of mass is the algebraic average, weighted average of the two position vectors. This is the center of mass. The kinetic energy Sure, we will learn the kinetic energy later, but kinetic energy is 1/2 mv squared, or momentum square, linear momentum square over 2m, and sum of the two particles kinetic energy is p1 squared m1 plus p2 squared 2m2. That is actually 2m1 plus m2 momentum, total linear momentum, p squared cm, plus 2 mu p squared. And I told you this is the conjugate momentum. P is reduced mass times first order time derivative of this relative coordinate. And here the reduced mass appears again. So this is the very basic nature of the two-body system. Reduced mass appears many times, remember. Okay, because acceleration is given in here, we can compute the displacement. Sure, at some point it will hit the pulley, but until the time before it reaches the pulley, they are making an uniform acceleration. And let us consider the case that their initial velocity and initial position to be 0. Then 1/2 at squared, 1/2 at squared, and a is given in here. Right. Let us compute the displacement velocity acceleration of the center of mass. Center of mass is defined in this way, and let us substitute these two. It is only the common factor. I have vectored this 1/2 at squared out. Then what I have to do is just weighted average of the unit vectors E1 and E2. Capital M in here, and small m in here, and divide this one by sum of the masses. Everything is determined. This is a constant vector. If we take the time derivative, what I have to do is a simple derivative of this that will give at. I can make another time derivative to find the acceleration with this. So in here we find that this guy is accelerating toward ground, so this portion is accelerating downward, but this guy does not fall at all. It is moving horizontally, so acceleration of this log above is horizontal. So acceleration magnitude of, even though the magnitude of the accelerations are the same, this x component of the center of mass translates to the right, and this guy translates downward. If we multiply the total mass to the system, I can obtain the linear momentum of the center of mass. And actually that is the sum of the momenta of the two particles. Again, I can take the time derivative of this, and I find this one. The center of mass, this is net force on the center of mass. That's net force on the whole system. So this is the net force on the system. And you can compute further what I have asked, but this is just training for the simple mathematics. It's not a mathematics, just arithmetic. Anyway, today we learned a lot, especially the big barrier. To most students who learn physics, They complain, I do not know mathematics. So I cannot solve the system of linear equation. Why not? It's very simple. Even in that case, you cannot solve. That's wrong. Just follow. It's just very simple. You don't have to learn any mathematics. What I have made use is just the cross product. Cross product measures the area of a triangle, and elementary school students can compute the area of a triangle, and middle school students can know how the two straight lines on the two-dimensional plane meet at a single point. You already know. But why, when you learn physics, you forget everything? It's very strange. You're in your high school, you're very smart. Why a freshman became so stupid and do not want to think further? But it is very simple. If you don't like stuff physics, but you will become to like physics. Physics is very simple and interesting. And this is the differential equation. You cannot solve. You have to learn differential equation in mathematics class. No, not at all. Even high school student can follow this calculation. It's not mathematics. It is just a simple trivial algebra. Don't be afraid. You can do everything. I don't ask you very, very difficult that you cannot solve. I can provide you a very simple physical problems. And have fun. That's it for today.